Hello, my viewers and students. Welcome to another lesson on gas chromatography. Today we'll be looking at some calculations carried out in gas chromatography. Don't forget to like, comment and share this video with your friends. Subscription is free, so subscribe to this channel. Subscribe. It costs you nothing. Let's look at the differences between gas solid chromatography and gas liquid chromatography. Gas solid chromatography uses stationary phases, and the method of separation is by adsorption of aniline molecules onto the solid stationary phase. It's primarily used for separating carbon dioxide, carbon monoxide, and nitrous oxide. It's also used for volatile organic compounds such as benzene, toluene, xylene, etc. It has limited applications due to the limited availability of suitable solid stationary phases. It has longer retention times and potential for peak tailing. The GSE columns are relatively shorter and have larger particle sizes, resulting in lower efficiency and broader peaks. And that is why gas-liquid chromatography is usually more useful. For gas-liquid chromatography, it uses liquid as the stationary phase. Separation mechanism is by partitioning of aniline molecules between the mobile phase and the liquid stationary phase, separated due to their different partition coefficients. Gas-liquid chromatography is more versatile than gas-solid chromatography due to the wider availability of liquid stationary phases. It is widely used for a broad range of applications, including the analysis of drugs, pesticides, fatty acids, and volatile compounds in various industries. Gas-liquid columns, especially capillary columns, can be longer and have smaller particle sizes, leading to higher efficiency and sharper peaks. On this slide is the chromatogram of petrol. And from the chromatogram, we have observed several peaks. It's interesting to note that 2-methyl-butane eluted first, also called isopentane, eluted first, followed by pentane. And they both have boiling point of 27.8 degrees Celsius for 2-methyl-butane and for pentane 36.1 degrees Celsius. It is expected that the 2-methyl-butane will elute first because it is a branch alkane. Branch alkanes generally have lower boiling points than their corresponding straight chain normal alkane isomers. We can also see from the chromatogram that 1,3-dimethylbenzene eluted before decaying. 1,3-dimethylbenzene has boiling point of 139 degrees Celsius, while decaying has 174.1 degrees Celsius. So it is expected that hydrocarbons with a greater molecular formula and longer carbon chain, such as decaying, will have a greater affinity for the stationary phase and a longer retention time. This makes sense as they will be capable of making stronger intermolecular bonds than 1,3-dimethylbenzene. When the chromatogram is recorded, the areas of the peaks are calculated manually, but now there are applications that can calculate it. Substances move at separate speed through the stationary phase, and the smaller substances will move faster than the bigger substances. You may be told to calculate peak areas and percentage peak areas. Like we have on this slide, a chromatogram showed a height of 27.4 millimeter and a width at half height of 3.5 millimeter for peak A, and a height of 42.4 millimeter
and a width at half height of 4.4 mm for peak B. And you're told to calculate the peak areas of A and B. And you are also told to calculate the percentage peak areas of A and B. You will calculate the peak area of A and B as area equals to height times width at half height. We know the peak A as 27.4, that is the height as 27.4 millimeter. And we have the width at half height for peak A as 3.5 millimeter. So we will multiply 27.4 millimeter times 3.5 millimeter. We are getting 95.9 millimeter squared. For peak B, we are given height as 42.4 millimeter and width at half height as 4.4 millimeter. When we multiply both, we will get 186.56 millimeter squared. We have answered the first question, the peak areas of A and B. Then the second one is the percentage peak areas of A and B. We are going to find out the total area. That means peak area A plus peak area B. And when we add both, we are going to arrive at 282.46 millimeters squared. Percentage peak area is equals to area of A over total area times 100%. Assuming you are looking for the percentage peak area of A, you will use this equation, area of A over total area times 100%. We are told that the percentage peak area A equals to 95.9 millimeters square divided by 282.46 millimeters square, which is the total area, multiplied by 100%. After solving, we got 33.95%. And for percentage peak area B, we applied the peak area of B, which was 186.56 millimeters squared, divided by 282.46 millimeters squared times 100%, and we got 66.05%. Assuming you're given some organic compounds with their relative peak areas and detector response factor, and you're told to calculate their concentrations. For benzene, the relative peak area given here is 25.4 and the detector response factor 0.09. You apply it into the equation. Benzene concentration equals to relative peak area divided by response factor, which will be 25.4 divided by 0.09, and we will have 282.22 ppm. We can also calculate for the concentration of toluene, styrene, and xylene. For toluene, we got 35.83 ppm, for styrene 330 ppm, and for xylene 51.36 ppm. When we get this, we are going to find out the total concentration, which is the addition of all the concentrations, and we are getting 699.41 ppm. We may be told to calculate the percentage concentration. Let's use benzene again. Percentage composition of benzene will be equals to individual concentration divided by the total concentration times 100%. Individual concentration of benzene is 282.22 ppm divided by 699.41 ppm multiplied by 100, and it will give us 40.35%. We can also apply the equation and calculate for percentage composition of toluene, which we got 5.12%, for styrene 47.18%, and for xylene 7.34%. We know that the retention time is very, very important in GC, and the retention time is the time taken for a component to pass through the column. The retention time is equal to the time of peak apex minus time of injection. For example, if you have a peak retention time of 8 minutes and the injection time is 2 minutes, what is the retention time of the peak? It is just taking those
values and applying to the formula, retention time will be equals to 8 minutes minus 2 minutes. It will give us 6 minutes. We can also be told to calculate the retention time, retention index, which is the retention index is a relative measure of a component's retention time, and it is given the formula retention time of component minus retention time of reference divided by retention time of reference minus retention time of previous reference and times 100%. So a component has a retention time of 15 minutes and the reference compound have retention time of 10 minutes and 20 minutes respectively. What is the retention index of the compound? Applying it to the formula, 15 minus 10 divided by 20 minus 10 times 100%, it gave us 50. Calculations continued. The peak height is a measure of the detector response at the peak apex, and the calibration curve is a plot of peak areas versus concentration, as we know, and concentration is equals to peak area minus intercept divided by slope. So you can be told to calculate the concentration of the component from a calibration curve that has a slope of 0.5, an intercept of 0, and peak area of the sample as 1,500 units. Concentration will be equals to 1,500 minus 0 over 0.5, which will give us 3,000 units. Let's attempt these questions at home. You are given a sample having methane, ethane, and ethylene in a gas chromatograph. 3 peaks appeared at retention time of 1.63, 2.008, 2.88, and its corresponding peak areas as given on the board. Calculate the concentrations of the 3 peaks. Also calculate the percentage concentration of the peaks. Question 2. Predict the order of separation based on both molecular weight and boiling points of the alcohols given to you on that table. You must be able to buttress your points why you think it should come up in that order. Thank you. Thank you as we have come to the end of this lesson. Don't forget to please like and subscribe to my channel. Share with your friend. Know that subscription is free. Thank you very much.